Hi, this is Biology in a Minute, and I'm Ms. Feldbush. Today I'm going to talk a little bit about enzymes. Enzymes are specific proteins that are designed to speed up chemical reactions inside living organisms. There are actually lots of ways to speed up chemical reactions. You can increase the concentration of the things that you're trying to get to react. You can put them under high pressure, or you can even increase the temperature. Unfortunately, most of these are not very possible within a living organism. If you do these things to an organism, you might kill it at the same time. So we need a better system. In non-biological systems, we have things that are called catalysts. Anything that speeds up a chemical reaction is technically called a catalyst. And you'll see on this graph that a certain amount of energy is required to make a reaction go forward. What catalysts do is, by optimizing the arrangement of the molecules, they allow that same reaction to happen, but with a lower input of energy. Enzymes are just proteins that are designed to do exactly the same thing. Because they're proteins, they work very well in living systems. However, because they work in living organisms, there are some limitations. One of the limitations is a limited pH range. Depending on where the protein is designed to work, if you put it at a vastly different pH, it's going to mess with the chemical bonds. Remember from the protein video when we talked about secondary, tertiary, and quaternary protein structure? Well, all of those are determined by chemical bonds, and those chemical bonds get messed up if the pH shifts too much. So some are designed to work at very low pHs, like pepsin, which is found in the stomach, and others are designed to work at higher pHs. But whatever the pH is, if you shift it, you're going to mess with the functionality of the enzyme and it's going to stop working. Here's a little visual of what happens when you start to mess with the pH. All of those bonds, like hydrogen bonds and disulfide bridges, all of those bonds that hold the protein together start to get messed up. And that causes the protein to sort of untangle or clump up. But whatever it does, it doesn't have the right shape to fit with the substrate anymore, and then it stops working. Another thing you can do to make a protein stop working or to denature an enzyme is to heat it up. If you think about cooking a steak, once you've cooked the steak, you can't uncook it. Same thing with cooking an enzyme. Once you heat it up too high, those bonds get stuck forever, and so you can't easily make them work the same way that they were supposed to. The last thing you need to know about enzymes is that they are specific. Specificity means that one enzyme usually works to catalyze one specific chemical reaction. We describe this often as a lock and key. When you look at the three-dimensional shape of the enzyme, it's got an active site in it, and that active site is designed to fit with a specific substrate. You can't take something else and expect it to fit in there and still carry out the same chemical reaction. So that's one of the reasons that enzymes are so common in the human body. There are so many chemical reactions, and each one is catalyzed by its own enzyme. So, in summary, enzymes are proteins that are designed to speed up chemical reactions, and by doing that, they allow those reactions to happen in conditions that are compatible with life. And being compatible with life is an important thing for chemical reactions in biology. Thanks for tuning in to Biology in a Minute.